Hello viewers, welcome to my channel. In today's lesson, we'll be picking up from where we stopped on the basic operation of surd. On our last video, we've worked on addition and subtraction of surd. So for today, we'll be working on the multiplication of surd. If you're joining us for the first time, I'll be dropping the link to addition and subtraction of surd and the introduction of surd in the description box below. So now let's start with what we have for today. Today we'll be working on the multiplication of surd. Now let's have this in mind before we can proceed to the examples. It said to multiply two or more surds, they should first be simplified if possible. Let's take note of this, if possible. So the if possible here means some question or some surd can actually come in their simplified form. So if they're already simplified, you do not need to take note of this. You can just multiply straight up. So but if they are not simplified, we need to break them down to their basic form. So after breaking them down to their basic form, we can now multiply whole number with whole number and surd with surds. Whole number with whole number and surd with surd. That's after simplification of surd. So now we have to recall this rule, which is in the introduction of surd. You can find the video in the description box if you're joining us for the first time. So it says root p times root q is equal to root p times q. That is, when we have separate surd, if we multiply them together, we can bring them under the same surd. More like saying root 2 times root 3 is equal to, when you bring them together, 2 times 3 under the same surd. So the other rule here says p root x times q root y is equals to pq root xy. So the p here is what stands for this: multiply whole number with whole number. So it's saying multiply p by q. So p here represents a whole number, q here represents a whole number. And then it said surd with surds. So we have the surd here, surd x and surd y. So that's how we have p times q, which is pq, then root x times root y, which is root xy. So it's the same as saying 2 root 3 times 3 root 5 is the same as multiplying whole number to whole number, which is 2 times 3, and root 3 times root 5. Root 3 times 5, bringing them together. So 2 times 3 gives us 6, root 3 times 5 gives us 15. So these two rules is the same as these examples given here. So now we have examples to work on. It says evaluate the following. Now for number 1, we have root 2 times root 3 times root 6. So we have to do this example 1 to 4 before we move to the next part. The next part says surd in bracket. Surd in bracket. So after doing example 1 to 4, we'll come to this part. So for example 1, we have root 2 times root 6 times root 3. Number 1, root 2 times root 6 times root 3. So we're working with the first rule I listed there, which says if we have roots p times root q, you bring them under the same root. So now it is already simplified. We do not need to simplify this first. It is already simplified. So it's going to be under the same roots. We have 2 times 6 times 3. Now multiply this together. When we bring them together, 2 times 6 gives us 12. 12 times 3. So we have our 12 times 3 to be 36. And 36 is a perfect square. So what is the square root of 36? The square root of 36 is 6. So this is the answer for number 1. Now let's move to example 2. For example 2, we have root 32 times root 12. Root 32 times root 12. So looking at this question, it is not simplified. So we have to simplify this to their basic surd. Then after that, we can multiply. So how do we simplify? We have to look for the factors of 32 and the factors of 12, whereby the factors, one of them will be a perfect square and the other one will be in a simplified number. That's a simple number, a small number. If you're joining us for the first time also, we've actually worked on this topic on the introduction of surd. You can actually look it up there. So now let's continue. For root 32, the factors of 32 can give us 16 times 2, where 16 is a perfect square and 2 is a simple number. Then we'll have times root 12. the factors of 12 is 4 times 3. 4 is a perfect square and 3 is a simple number. So now we'll have to split this. We'll have root 16 times root 2, and then we'll have here root 4 times root 3. Root 16 gives us 4. That's the square root of 16 gives us 4. Then times root 2. We'll bring it together. Times square root of 4 gives us 2. And then our root 3. We'll bring it together. So now we've been able to simplify this to this. So root 32 times root 12 in a simplified form is 4 root 2 times 2 root 3. Now we are going to multiply this. We are going to multiply this. So 4 root 2 times 2 root 3. Remember, it says after you simplify your surd, it is going to be whole number to whole number, surd to surd. So whole number to whole number will have 4 times 2. Let's put it in a bracket, and then we'll have surd to surd, which is root 2 times root 3. So 4 times 2 gives us 8. Then remember the rule of surd, just like we did in example 1. If they are separate, you bring them under the same surd. So it becomes surd 2 times 3. Our answer is equals to 8. Root 2 times 3 gives us root 6. So the answer here is 8 root 6. Now let's go to example 3. Example 3 says root 12 times 3 root 60 times root 45. Number 3, root 12 times 3 root 60 times root 45. So now this is not in a simplified form, so we have to break it down to their simple form. 12, we have two factors to be 4 times 3. Then we'll have here to be times 3. Then factors of 60 should be 4 times 15. 4 is the perfect square. Then we'll have 49 should be 9 times 5. Remember the rule, one must be a perfect square and the other should be a simple number. You can actually say 15 is not a simple number. We can still get 3 and 5. Just know that among 3 and 5, or between 3 and 5, no one is a perfect square. So we can work with 4 times 15 for root 60. So now let's split the perfect square away from the simple number. So we have root 4 times root 3 times 3 root 4 times root 15 times root 9 times root 5. So what's the square root of 4? The square root of 4 gives us 2. So 2 root 3 times 3 times root 4 gives us 2. Then we'll have our root 15 times square root of 9 gives us 3. We'll have our root 5. So 2 root 3 times 3 times 2 gives us 6 root 15 times 3 root 5. So we have to bring the whole numbers together before we work with the surds together. So working with the lines I drew here, we'll have 2 times 6 times 3 for the whole number, and for the surd we'll have root 3 times root 15 times root 5. Let's put it in a bracket. So 2 times 6 is 12. 12 times 3 gives us 36. And then we'll have to bring all this together. 3 times 15 times 5. So this is equal to 36 root. We have to multiply every number in the surd. 3 times 15 gives us 45. 45 times 5 gives us 225. So you will agree with me that 225 is a perfect square. Yeah. 36 times 225 is a factor for 15 times 15. So we can say that the square root of 225 is 15. So 36 times 15 is equal to 540. So this is the answer for number 3. So for number 4, we'll have the cube of 2 root 3. 2 root 3, the cube. So whenever we have a number raised to the power of 3. That's the cube of a number. It means we should multiply that number 3 times. Just like when we have the square of a number that's raised to the power of 2, we multiply 2 times. So here we'll be multiplying 3 times. So 2 root 3 times 2 root 3 times 2 root 3. So this is 3 times 1, 2, 3. Now we'll collect the whole numbers 2, 2, and 2. Multiply them together. 2 times 2 times 2. Now we'll move to the surd. We'll have root 3 times root 3 times root 3. So root 3 times root 3 times root 3. Now 2 times 2 is 4. 4 times 2 gives us 8. And then for our root side, we'll have root 3 times root 3, which will give us root 9 times root 3. Root 3 times root 3 gives us 9 times root 3. Take note of that. So now the square root of 9, because 9 is a perfect square, so the square root of 9 gives us 3. So we'll have 8 times 3, and then we'll have our root 3. So 8 times 3 gives us 24 root 3. So our answer for number 4 is 24 root 3. Now let's move to the surd in brackets. So the next is surd in brackets. So bracket means multiplication in mathematics. I want us to remember this. Bracket means multiplication in mathematics. So when multiplying surds in brackets, we use algebraic expansion. So I actually made us remember this and this. These are algebras. So I want us to see the expansion and how it works. So let's apply that to surd. So now the first time here we'll have a bracket b plus c. So remember the bracket means to multiply. So we have to expand this. So which means a times b, which is ab, then a times plus c gives us plus ac. Then the next expansion here says a times c gives us ac. Then we'll have a times plus d gives us plus ad. The next one is b times c, that's plus b times c gives us plus bc. And then the last, which is b times d plus b times plus d gives us plus bd. So just as the way we expand this is exactly how we're going to be expanding in the following examples. So it says simplify the following. We have 2 root 5 bracket 3 root 5 minus 2 root 2. So let's do number 1 first, then we'll apply the idea we might have used for number 1 to solve number 2, 3, and 4. Number 1. Number 1 says 2 root 5 bracket 3 root 5 minus 2 root 2. So just as we expanded this first part of the algebra by saying a times b and then a times c. So that way we're going to be expanding this by saying this times this first before we can say this times this. So now let's do the first one. So working with the first one, we'll have 2 root 5 times, we have 3 root 5. So this is 2 root 5 times 3 root 5, and then we'll come to the other part. It says 2 root 5 times minus 2 root 2. Because of the minus sign here, we'll have to put our minus here. So we'll have 2 root 5 and then times 2 root 2. I'm actually using the times here because of this is surd. We cannot just multiply immediately like that. So we have to work with the rule of multiplication so we don't mix things up. So this minus sign here, we have it here. It's just like saying 2 root 5 times minus 2 root 2, which is minus 2 root 5 times 2 root 2. So now let's proceed. So the rule of multiplication, let's remember it says whole number to whole number, then surd to surd. So whole number here is 2 times 3, and then for the surd we'll have root 5 times root 5. Then we'll come to this part, minus whole number to whole number, we'll have 2 times 2, and then surd times surd, we'll have root 5 times root 2. So now 2 times 3 gives us 6. Now bringing the surd together, we'll have 5 times 5. Let's move to this side. 2 times 2 here, we'll have 4. Bringing this all together, we'll have 5 times 2. So 6 times 5 times 5 gives us 25. Then we'll have minus 4 roots. 3 times 2 gives us 10. So let's remember that the square root of 25, that's 25 is a perfect square. So the square root of 25 is 5. So we'll have 6 times 5 minus 4 root 10. We could have probably say, let's pick one here. That's 5 times 5. The roots. Now, I told us in the first video where we introduced Surd that root p times p is the same as p. That's, you just have to pick one. It's just like saying root p square, whereby the square will cancel roots equals to p. So it's the same as saying 5 times 5 is just equal to 5. That's root 5 square. If square cancel square root, it will give us 5. So instead of going through this 5 times 5, 25, then you come back to 5, you could have just used any of this. You can just use this. So now we'll have 6 times 5. 6 times 5 gives us 30 minus 4 root 10. So this is the answer for number 1. Now let's move to number 2. Question number 2 says 3 root 5 plus 2, then another bracket, root 5 plus 3. So now let's expand just like we expanded this one, whereby we say A times C, then A times D. So one at a time. Let's do that here. Now, 3 root 5 times root 5. So 3 root 5 times root 5. And then we'll have 3 root 5 times plus 3. It will give us plus 3 root 5 times 3. The next one is plus 2 times root 5 will give us plus 2 root 5. And then we'll have plus 2 times plus 3 will give us plus 2 times 3. So we've broken it down, this, 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 and this. That's what we got from expanding these numbers. So the next thing is 3. Root 5 times root 5 are going to bring it together. That's root 5 times 5. And then we'll have here to be whole number to whole number. This is whole number here, and this is whole number. That's 3 times 3. So 3 times 3 gives us 9, and then we'll have our root 5. Then we'll come here plus 2 root 5 plus 2 times 3 gives us 6. So just like we did in number 1, the square root of 5 times 5 is 25. And what's the square root of 25? It is 5. Or we say the square root of 5 square is just 5. So 3 times 5 plus 9 root 5 plus 2 root 5 plus 6. 3 times 5 gives us 15 plus 9 root 5 plus 2 root 5 plus 6. So now we'll have to collect like terms. This has led us to addition of Surd. So 15 plus 6, this is a whole number, we'll bring it together, 15 plus 6, and we'll bring the Surd together, plus 9 root 5 plus 2 root 5. So 15 plus 6 is 21 plus 9 root 5 plus 2 root 5. These are like terms. Root 5 and root 5 are alike. So just like we did in addition of Surd, since they are alike, we have to add the whole numbers together and pick one of the Surd. So 9 plus 2 gives us 11 root 5. So this is it. It's just like saying 9x plus 2x. We'll pick the numbers. 9 plus 2 gives us 11, and then we'll have our x. So this is how we work with like term in algebra and also in Surd. Now let's move to number 3. For number 3, we'll have 3 root 3 minus 2 root 2. Root 2 minus 2 root 3. So now let's expand this times this first. So we'll have 3 root 3 times root 2. And then we'll have this times minus 2 root 3. So we have minus 3 root 3 times 2 root 3. Then we'll have minus 2 root 2 times root 2. So minus 2 root 2 times root 2. And then we'll have the last one, minus times minus. Minus 2 root 2 times 2 root 3. So minus times minus is plus. Then we'll have our 2 root 2 times 2 root 3. So now let's work with surd will multiply surd. Then we'll have our 3 root 3 times 2. They will have to come under the same umbrella. Then we'll have minus whole number to whole number, we'll have 3 times 2. And then surd to surd, we'll have root 3 times 3. So we come here, we'll have minus 2. Then surd times surd, we'll bring it under the same surd. 2 times 2 plus 2 times 2 gives us 2 times 2. And then the surd together, root 2 times root 3 will come under one surd, 2 times 3. So now we'll have our 3 roots. 3 times 2 is 6 minus 3 times 2 gives us 6 roots 3 times 3 is 9 minus 2 root 2 times 2 is 4 plus 2 times 2 gives us 4 roots 2 times 3 gives us 6. So we have our 3 root 6 minus 6 root 9. The square root of 9 gives us 3 minus 2 times, then the square root of 4 gives us 2 plus 4 root 6. So we have 3 root 6 minus 6 times 3 is 18 minus 2 times 2 is 4 plus 4 root 6. So now we have to collect like terms, or let's say collect like surds. So 3 root 6 plus 4 root 6, these are together, this and this, they are like surd. And then we'll have a minus 18 minus 4, which is the whole number here. So now 3 root 6 plus 4 root 6 gives us 7 root 6. So minus 18 minus 4 gives us minus 22. So this is the answer for number 3. Now let's move to number 4, which is the last question in this video. Number 4 says 2 root 2 plus root 5 all square. So we have to look for the square of 2 root 2 plus root 5. So this is the same as saying we should take this surd and multiply it twice. That's multiply it by itself. You get. So 2 root 2 plus root 5, we have to multiply it by itself, which is 2 root 2 plus root 5. So now let's expand. 2 root 2 times 2 root 2. So we have 2 root 2 times 2 root 2. Then we have 2 root 2 times root 5. That's plus root 5. So plus 2 root 2 times root 5. And then we'll have root 5 times 2 root 2 plus root 5. So plus root 5 times 2 root 2. Then we'll have the last one plus root 5 times plus root 5. So plus root 5 times root 5. So here we'll have whole number times whole number, surd times surd. So the whole number here is 2 times 2. And then for the surd, we bring them under the same surd. 2 times 2, that's root 2 times 2. Then plus, we have just one whole number here, whole number 2. And then for the surd, we have root 2 times root 5. So 2 times 5 plus surd times surd. Then we'll have whole number 2. So the whole number comes first. Then root 5 times root 2 is the same as 5 times 2 under the same surd. Then plus root 5 times root 5 means root 5 squared. That's root 25. 5 times 5 will give us 25 when we bring it under the same surd. And then we can just say root 5 times 5 is the same as root 5 square. So if we have root 5 square, square cancels square, then we'll have our 5. So now 2 times 2 gives us 4, root 2 times 2 gives us 4, plus 2 root 2 times 5 gives us 10, plus 2 root 5 times 2 gives us 10, plus we have our 5 left here. So now for the square root of 4, it is 2. 4 times 2 plus 2 root 10 plus 2 root 10 plus 5. So for this 2 times 2, you can actually apply this method here, whereby you say root 2 square is 2 times 2. So square cancel square root will give us 2. So that way you will get root 2 times 2 is equal to 2. So that aside, 4 times 2 gives us 8 plus 2 root 10 plus 2 root 10 plus 5. So now we have to collect like term, whole number to whole number, surd to surd. So collect like surds, 8 plus 5 plus 2 root 10 plus 2 root 10. So our answer here is 8 plus 5 gives us 13 plus 2 root 10 plus 2 root 10. That's the whole number plus whole number. Then we have one surd. 2 plus 2 gives us 4 root 10 because they have the same root, 10 root 10. So we are going to pick one. So this is the answer for number 4. And the last question we have to solve for this video. If you have any question concerning surd and its subtopic, it could be reduction of surd to basic form, expressing surd as a single surd. It could be the basic operation of surd, whereby you need to ask question under maybe addition, subtraction, division, multiplication, or even the conjugate of surd and rationalization of surd. Do well to drop it at the comment section. I will check them and reply your questions. So thank you very much for joining me in today's class. See you in my next class. So my next class will be working on the division of surd. So you should have that in mind and prepare accordingly. Take care of yourself. Bye.